Hello, welcome back to the short lectures in physics series. The topic for discussion in this session is special cases in projectile motion. A projectile is a body that is thrown into air at an angle with an initial velocity and made to travel under the influence of gravitational force alone is called a projectile. So the projectile has got motion in both horizontal and vertical directions. Thus, its motion can be described as a two-dimensional motion in a plane. So now we discuss other cases of projectile in which the body is projected at different angles of projection with some initial velocity. The first case is body projected at an angle with the vertical. So far we have discussed about the body projected at an angle with the horizontal axis. Now the topic now is the body is projected with an initial velocity u0 making an angle with the vertical axis theta. So then the angle of projection made by the body with the horizontal axis is 90 minus theta. So in all conventional equations derived for projectile motion can be used here with a change in theta as 90 minus theta. So we can derive expressions for the range, maximum height, time of flight, etc. The time of flight in conventional means is 2 u0 sin theta by g. By replacing theta with 90 minus theta, this becomes the time of flight, that is time taken for the projected body to fly to maximum height h and then come back to the ground at the certain horizontal distance, that is range. So this time of flight is given by 2 u naught cos theta by g instead of sin theta, because sin 90 minus theta becomes cos theta. So the time of flight is 2 u naught cos theta by g. Similarly, the maximum height is u naught square sin square theta by 2g. So again replacing theta with 90 minus theta, you get h max is equal to u naught square cos square theta by 2g. Similarly, range becomes u naught square sin 2 theta by 2g. So this becomes range becomes u naught square sin 2 theta by 2g. Now let us see the velocity at any time of the projectile at any time t. U is equal to u naught square plus gt square minus 2 u naught gt sin 90 minus theta to the power of. So that becomes u naught square plus g square t square minus 2 u naught gt cos theta 9 sin 90 minus theta, wherever it comes it becomes cos theta, it's under root. So total is under root square root of. Similarly, angle made by the projectile at any time t with the horizontal axis is given by tan alpha is equal to tan 90 minus theta minus gt by u naught cos 90 minus theta. Theta has been replaced by 90 minus. That becomes cot theta minus gt by u naught sin theta. Similarly, the trajectory equation can be written as y is equal to x tan 90 minus theta minus g by 2 u naught square cos square 90 minus theta x square. So this is a parabolic equation. So that becomes y is equal to x cot theta minus g by 2 u naught square sin square theta times x square, which is again a parabolic equation. So the trajectory again is a parabola. Now we see the other case. Body is projected horizontally. That means projected horizontally, that is theta is equal to 0 with an initial velocity u naught from a height h above the ground. So the horizontal velocity, as usual, it remains constant at u naught throughout the trajectory of the projectile motion, and the vertical velocity is 0 at the time of projection, because only horizontal velocity and vertical velocity is 0 at the maximum height. Later it increases uniformly till it touches the ground. So again the trajectory is a parabola. So the examples are: a bomb dropped from an aeroplane will follow parabolic path and always travel below the aeroplane and will have some range. So what does it mean? If you drop a bomb from an aeroplane aiming at an enemy's target, then To observer sitting in the aeroplane, it looks like as if the bomb is falling vertically down, because the bomb speed is nothing but the aeroplane speed, because it is being projected with the speed of the aeroplane. So to the observer sitting in the aeroplane, it looks as if it is falling down, but actually to an outsider, the bomb moves horizontally in a parabolic path and drops at a further distance from the point of its projection. So if the air resistance is also taken into consideration, then the horizontal velocity of the bomb gets reduced in its downward motion, because air resistance is there. So its velocity gets reduced, hence it falls below the aeroplane. Hence the bomb looks as if it is falling on the ground behind the aeroplane. That's its range is getting reduced. So let us find out the equations for this. The time of flight is obtained by using t small t is equal to capital T, that is the time of flight, and y is equal to maximum height h in the present case. So y is equal to u naught sine 0 degrees into t minus half gt square. Sine 0 is 0, so you will get half gt square. So that time of flight is equal to twice h by g under root square root of 2h by g. Height is the height from which the body is projected, and g is the gravitational acceleration due to gravity of the planet. Similarly, range is obtained by substituting x is equal to range, x distance is range, and time of flight is equal to the time under the equation. So x is equal to u naught cos 0 into t. Cos 0 is 1, so it becomes u naught t t. So range becomes u naught into capital T, that is time of flight. Time of flight is under roots 2h by g. So u naught 2h by g under root. Horizontal motion, if you want to find out the position of the body horizontally at any time t, then horizontal motion at any time t is given by x is equal to u cos naught t, that is equal to u naught t. T is any time of instant, whatever time you are under consider, 2 seconds, 3 seconds, like that. Similarly, vertical motion is u naught sine 0 t minus half gt square, that is equal to half gt square, because sine 0 is 0. And velocity at any time you want to find out, then u is equal to, equations are u naught square plus gt square minus under root minus 2 u naught gt sine 0, total is under root. So you will get u under root u naught square plus g square t square. Similarly, the angle made by the body at any time t with the horizontal axis tan alpha is given by minus ua by ux, that is minus u naught sine 0 minus gt by u naught cos 0. Sine 0 is 0, so gt by u naught cos 0 is 1. So tan alpha is given by gt by u naught, or alpha is equal to tan inverse gt by u naught. The trajectory equation can be given as y is equal to half gt square, that is half g into x by u naught square, because the cos theta term is 1, that is equal to g by 2 u naught square into x square, which is in the form of y is equal to mx square, again a equation for parabola, hence the trajectory is again a parabola. So these are the two special cases in projectile motion. One is projected at an angle with the vertical axis and projected horizontally from certain height h. Now see some of the numericals, the applications of these situations in actual conditions. Now a bomb is dropped from an aeroplane flying at 210 meters height with a speed of 78 meters per second. So now we want to find out the horizontal distance from the target at which the bomb should be dropped from the aeroplane, and velocity with which the bomb hits the target. There is a target, so before you reach the target, you have to release the bomb. So you have to find out at what distance you have to release and what is the velocity with which the bomb hits the target. So considering the vertical motion of the bomb dropped from aeroplane, vertical motion is freely dropped falling body. So y is equal to u naught t plus half gt square, that is 210 is equal to half 9.88 t square. So t becomes 6.5 seconds. and the distance at which the bomb should be dropped, that is before the target, at what distance you have to release the bomb is range. So R is equal to U naught into T. So U naught is 78 meters per second is there. So 78 into 6.5 is the time. So 507 meters before the target you have to release the bomb. The velocity component in vertical direction of the bomb at the time t is given by Vyt is equal to Gt, that is 9.8 into 6.5. Yt is 6.5. We want to find out the velocity at which the bomb hits the target. For it takes 6.5 seconds to hit the target. So Gt 6.9.8 into 6.5, that is 64 meters per second is the velocity in the vertical direction when it is the target. Similarly, velocity in the vertical component, that is remains same at every point. So Vxt is given by u naught 78 meters per second. So velocity of the bomb, relative resultant velocity is given by v is equal to square root of Vxt square plus Vyt square. So you will get square root of 78 square plus 64 square, that is 100 meters per second is the velocity at which it hits the target. Now, a boy throws a stone upwards from his window. So he is throwing a stone from his window to opposite his friend's window, that is across the street, which is 40 meters wide. The road is 40 meters wide. So on the other side of the road, there is another building. His friend's window is there. So he wants to throw a stone from here to his friend's. So if the boy's window is 10 meters below the window of his friend's, how should he throw the stone? So the road width is nothing but half the range. Thus r by 2 is equal to 40 meters. So r is equal to 80 meters. Now for a given velocity u naught, the h by r is 1/4 of tan theta. So tan theta becomes 4 into 10 by 80, that is 0.5. Thus the stone has to be projected at an angle of 26.56 degrees. So velocity with which the stone has to be projected is square root of 2gh by sin 2 theta. That you will get it as 31.3 meters per second. Now, an object is thrown vertically from top of a tower and strike the ground after 3 seconds. That means 3 seconds. The total time of travel is 3 seconds at an angle of 45 degrees. So with the horizontal, then the height of the tower and speed with which the body should be thrown are to be known. Again, considering vertical motion of the body, h is equal to u naught t plus object height to which it reaches above the tower. So that you will get it as 44.1 meters. The vertical velocity component in vertical direction of the object after 3 seconds is Vyt, that is equal to Gt, because initial velocity u is 0 from maximum height. So 9.8 into 3, that is 29.4 meters per second is the velocity in the vertical direction. Velocity component in the horizontal direction is u naught, that is same, remains same everywhere. So, and it is also given that the object hits the ground at 45 degrees. The object is hitting the ground at 45 degrees after 3 seconds. So tan 45 is equal to Vy3 by Vx3. 3 is 3 seconds of time. Time of flight is 3 seconds. That becomes 1. Hence, the 29.4 by u naught is 1. And hence, velocity with which the object is to be thrown is 29.4 meters per second. An aeroplane flying at 150 kilometers per hour is supplying food items to victims who are standing on an isolated land 250 meters below. So how many seconds before the supply should be dropped before plane reaches the land, above the land? So considering the vertical motion of the food supplies, the height of the aeroplane above the ground is given by half gt squared, 250 meters. Thus the time can be obtained as square root of 252 into 250 by 9.8, which is 1.1 seconds. Now, a ball is thrown horizontally from top of a building with a speed of 40 meters per second. From the top of a building. Its velocity and position after 4 seconds has to be found. So, uniform horizontal velocity is same. Ux naught is uxt 40 meters per second, and vertical velocity uy naught initially is 0, Vertical velocity after 4 seconds is v u by 4 is gt, that is 39.2 meters per second. So resultant velocity after 4 seconds is u is equal to square root of u x 4 square plus u y 4 square. That you will get it as 56 meters per second. And horizontal distance, that is the range traveled by the ball in 4 seconds is x is equal to vx naught into t, that is 40 into 4, 160 meters. And the vertical distance traveled by the ball in 4 seconds is y is equal to half gt square, that is half 9.8 in 4 square, that is 78.4 meters per second. These are some of the examples where the special cases of projectile motion can be seen applied. Hope this will be useful to you. This talk will be useful to you. See you in the next talk. Bye.